Hey guys, welcome to my channel. I'm LeetCode. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have an amazing problem, guys, that I'm very excited about. So let's go ahead and read the problem statement, guys. So the problem's called number of connected components, right, in an undirected graph. So it says you have a graph, right, of n nodes, right? It says we're given integer n and an array edges, right, where edges of I. Where every array, right? So it can be a 2D array, right? Every array, right, is going to be represented on the, so we have a sub I, b sub I, right? Pretty much those are going to be two labels, right? Two nodes, right? They're connected to each other, right? So this is what the edges stand for, right? So yeah, so it indicates that there is an edge between those two labels that are given to us, right? So that's what they said here, right? So we say return the number of connected components, right, in the graph, right? Okay, guys, she's a you can see, even see, guys, she's a very good problem. She's something that we might be able to do, right, with the knowledge that we acquired by um watching the playlist that we have here on this channel that we're building, actively building, guys. So it's gonna be a good, we're trying to build a good, strong graph playlist so you guys could be ready for your interviews, guys. So something might pop up, you guys might check out the playlist that I have, guys. So example one, right? So where you see that we're looking at this, right, we could easily see that there's just two components, right? Because 0, 1, 2 are connected, right? And then we got this other component, right? 3, 4, right? We just form another component, right? Which are made it, right? So pretty much we have pretty much two things right there, right? Two components, guys. So that's why we return two, guys, because our job, right, is going to be to find the number of components, right? So we see that easily. So we see this one, right? You see 0, 1, 2, 3, 4. You see they're all connected, guys, right? So it's one big graph, right? So because of that, guys, we have one component, right? So yeah. So this question kind of gives us the same vibe as the number of island problem that we did on this channel before. I did it way back, but I think it kind of help us with this particular question, right? But yeah, so this kind of walk through the thought process that's kind of needed to solve this, guy. So you're probably saying, how can we know that the different components, guys, right? How can we do that? Right? There's this problem. There's just so many ways to solve it, guys. Very creative ways, different traversal, different algorithms, or different stuff that we could use, guys. So the easiest way is going to be pretty much, guys, the same way as we did for the number of islands problem, right? So pretty much, guys, what we're gonna do, pretty much do a depth first search traversal, right, of the graph, guys. So we loop through. So pretty much, we create the graphs, right, and after we create the graph, we traverse, right. So every time that we get one node for each component, right. So we get one node and then we visit the whole graph, right, every single node and that component, right. We're gonna visit it, right. So we're gonna visit that and then also visit everything. So they all count as the same component, right? So we won't come back from the traversing this component until we visited all of the nodes in there, right? So and then once we visited all the nodes, right, we check it, are there any nodes that were given to us, right, that we didn't visit yet, right? If there's still some nodes, then we're gonna visit them, right, accordingly. So 3 and 4 haven't been visited, right? So we would visit 3 and 4, and then everything would be visited, and then we would have this counter that's gonna keep track of the number of times we've had to visit a component, right? So there's 2 times, right? We had to visit 2 components, right, to visit all the nodes, pretty much, right? But this one, right, see 0, right? Well, once we start with 0, and then we check 1, 2, 3, 4. We visit every node that's connected, right? I'm saying, right? So because of that, guys, we are gonna say this is 1, right? Because we in one go, we've been able to visit all of the nodes, guys. So that's kind of how the thought process and how we want to solve this question, guys. So yeah, there's other ways you could solve it as well. I know there's other more clever way. You could use union find. I haven't taught you guys that yet. This is why I didn't brought it up. You could also in BFS to traverse, right? up to you, up to what you like to do, right? But I think the DFS can be very clean, very chill, right? We could easily do that with DFS. That's why I'm using DFS, guys. So up to you, man. I'm saying. So yeah, guys. So you guys understand what's going on. So pretty much what we're gonna do, we're gonna build a graph, right? Up to you what kind of representation you want to use. We always went with the adjacency list representation of the graph. So this is exactly what we're gonna do, guys. And after we do that, we continue doing what we gotta do, right? So guys, yeah, let's go ahead and yeah, and go ahead with it. Right. So pretty much what we're gonna do, guys, we're gonna have a map, which is gonna be of integer to a list of integers, right? If you guys don't know what I'm doing right there, guys, please visit my graph playlist, guys. It's all gonna make sense, right? This is how we're gonna represent it in memory, right? The graph, right? So we're giving the edges, right? So edge is gonna be edge and edges, right? And for error in U, it's undirected, right? So that's a very good thing that we need to worry about, right? Right. So that means, right? So that we G that get U, right? Add V, right? And then we do the same thing in reversed. Because it's undirected, so it goes both ways, guys, right? Okay. So once we do that, guys, what's the next thing that we do? So we have the graph, right? So now we're gonna have a set, right? Which is important. Integer, right? Call it set. You have set, right? And then now, guys, we're gonna loop through every single node, right? And yeah, so the n tells us there's how many nodes, right, that are given to us in the right. We have a graph of n nodes, right? So that's why the n tells the amount of nodes, right? So I assume they're labeled from 0 to n minus 1, right? That's all they're labeled, right? Yeah, this is what it is, right? Yeah, okay, that's important. Yeah. And then we do I++, guys. I++. So let me copy that real quick. I think I'm gonna need that right there to initialize the graph, right? G that put I, and then we're gonna put some kind of so I just created allocated memory for the list that we're gonna be adding our neighbors to, right? So now we're gonna visit, guys. So pretty much we're gonna do a check with the set that contains I, right? If the set does not contain I, right? So if that node has not been visited yet, right? Then we're gonna have a DFS function that's gonna pretty much help us in doing the DFS, right? So we're gonna pass in I, and we're gonna also pass in the set, guys, right? Which is very, very important. And then we're gonna have our counter right there, and count. All right, or you could call it, count, right? Whatever you want to call it. Okay, keeping it I'm saying easy, right? So count plus plus. After that, we should simply return, guys, that count, right? After we do all that, right? So pretty much you see it's very, very similar to the number of islands, right? So the next thing that we're gonna do, guys, pretty much build our what's it called? Build our function, right? So let me zoom out real quick. Public int. I mean, do we need to return anything? Nope, not at all. All right, DFS. So we promised that when we're gonna get the node, right? And then we're gonna also get the integer, guys, which is important, right? So after we do that, get the set, right? So if the set that contains node, now return, guys, right? We don't want that, right? If it contains that, right? We don't want that. And if it's not doesn't contain it, then we add it to the set, right? And then what we're gonna do, we're gonna visit all of that node's neighbor, right? So let's call it int neighbor, which is gonna be g dot get, right? Get that node, right? Get all of its neighbor, right? Yeah, so somehow I need to pass the graph, right? It's kind of important. I mean, right? I mean, how do I reference it, right? All right. So we see that. The next thing that we can do, we check the DFS neighbor, right? So passing the graph, passing the neighbor, also passing the set, guys, right? And yeah, looks pretty good. Let's press run code. All right, looks like we passed the small test case, guys. Let's see if we pass all the test cases. Awesome, guys. We're able to pass all the test cases on our first try, guys. So that's very good. It's really good, you know, well, you know, for the confidence, what I'm saying, to keep going, to, you know, start to keep doing this problem, guys. So yeah, so as you can see, it's a very simple solution. Let me know if you have any questions in the comment section. I'll try to respond to it and help you guys out. So yeah, I want to thank you guys for, you know, watching this video. I'm saying, please guys, please give me a like. I would really appreciate it. It really helps out the channel a lot. You know what I'm saying? Comment, like, subscribe if you haven't already done so. So yeah, I want to thank you guys for watching, and I'll see you guys in the next one.